Hello everyone, welcome back to my channel. This is Narshoha. I'm here with another video after a long time. Hope you enjoy this video. If you like my video, so please subscribe to my channel. Today we are going to talk about inferential statistics, estimation and hypothesis testing. So let's proceed. First of all, what is inferential statistics? It is a branch of statistics that involves making predictions, decisions, or generalizations about a larger population based on data collected from a sample of that population. Unlike descriptive statistics, which focuses on summarizing and describing data, inferential statistics uses probability theory and statistical methods to draw conclusions and make estimates. Uh, it has some key concepts, which are population and sample estimation, hypothesis testing, statistical significance, confidence intervals, regression analysis, and sampling methods. As we can see in the slide, there are two types of inferential statistics. One is parametric and the other is non-parametric. So let's find out what is parametric and non-parametric. Parametric testers are which assume a specific probability distribution for the population data. They rely on parameters like mean, variance, etc. It assumes data comes from a known distribution like normal or binomial. It uses parameters like mean and standard deviation. It generally requires larger sample sizes for reliable results. It is more powerful and precise if the assumptions are met. The examples of parametric tests are t-test, ANOVA, Pearson's correlation, linear regression, etc. It is more efficient with smaller sample sizes if assumptions are met. It provides exact probability values, but it has also some disadvantages. The results are unreliable if assumptions are violated. Then comes the non-parametric test. These are statistical tests that do not assume any specific distribution for the population. They are also known as distribution free tests. It makes fewer assumptions about the data. It is useful when the data is ordinal, categorical, or not normally distributed. And it can be applied to small sample sizes. So it is usually less powerful than parametric test but more robust. The example of non-parametric tests are Mann-Whitney U test, Kruskal-Wallis test, Spearman's rank correlation. It is used with ordinal or non-normally distributed data, but it has some disadvantages. It is less powerful than parametric test when parametric assumptions are met. It provides less precise estimates. So we came to know about parametric and non-parametric. Then let's proceed to the next slide, which is said estimation. Estimation is a different topic, so let's start to know what is estimation. First of all, estimation is a process in inferential statistics used to predict or determine the approximate value of a population parameter based on sample data. Since we usually cannot study an entire population, we take a sample and use estimation techniques to infer information about the population. There are mainly two types of estimation. One is point estimation and the other is interval estimation. So point estimation provides a single specific value as an estimate of a population parameter. It's simple, but it doesn't provide information about the accuracy or reliability of the estimate. For example, sample proportion is an estimate of population proportion. And another example is using the sample mean to estimate the population mean. Then moving to the next slide, which is interval estimation. It is also called confidence interval. It provides a range of values within which the population parameter is expected to lie with a certain level of confidence. For example, 95%. Say, for example, the average height of students is estimated to be between 170 centimeter and 175 centimeter with 95% confidence. It gives more information than point estimation by indicating the precision and reliability of the estimate. There are some key differences between point estimation and interval estimation. The complexity of point estimation is low, but the complexity of interval estimation is moderate to high. The reliability of point estimation is lower, but the reliability of interval estimation is higher. So we came to know about estimation, then move to we'll move to hypothesis testing. So let's get to know what is hypothesis testing. It's also a statistical method. Hypothesis testing means a formal procedure to determine whether there is enough evidence in a sample to support or reject a specific claim about a population parameter. The examples of hypothesis tests are Z-test, T-test, chi-square test, ANOVA, etc. There are some steps to in hypothesis testing, which are um, conducting the null and alternative hypothesis, providing the significance level alpha, fixing the p-value, and then after, if the p-value is less than or equal alpha, we so if the p-value is less than or equal alpha, we reject the null hypothesis, which means evidence support the alternative hypothesis. But if the p-value is greater than alpha, we fail to reject a null hypothesis, which is it is insufficient evidence to support alternative hypothesis. And lastly, we'll draw a conclusion by stating the findings in the context of the original research questions. But in hypothesis testing, there can be some types of error. There are mainly two types of error. First one is type 1 error and the other is type 2 error. Type 1 error is also called false positive. It means rejecting a true null hypothesis, which means concluding there is an effect when there actually isn't. For example, a medical test wrongly indicates a person has a disease. To minimize this error, we have to lower alpha, but this increases the risk of a type 2 error. Then the type 2 error is also called as false negative, which means failing to reject a false null hypothesis. The probability of occurring type 2 error is referred to as beta. The consequence of it is missing a true effect or relationship. For example, a medical test fails to detect a disease that is actually present. To minimize this error, we have to increase sample size, increase a increase alpha, though it raises the risk of a type 1 error, and improving experimental design. Another concept related to error is statistical power. It means the probability of correctly rejecting a false null hypothesis, which means detecting a true effect. The formula of the power is 1 minus beta. High power is desirable to reduce the likelihood of type 2 errors. Between type 1 and type 2 error, the severity of type 1 error is often considered more serious, but type 2 error is less serious but can be problematic. And the minimization method of type 1 error is decreasing alpha. The minimization method of type 2 error is increasing sample size or power. So in this video, we tried to give a overall view of estimation and hypothesis testing, which is very important in research methodology. I hope you would like this video, and this video will be beneficial for your studies. So thank you everyone for listening to me. I hope we'll return with another video. Till then, Stay tuned with me. Thank you.